Good day viewers, welcome to my channel Mathematics Clinic by Tutor Chris. So in today's video, I want to discuss something that is very important to you. I want to make use of this variable concept, that is finding the how to find the sum of integer, the sum of square of integer, the sum of cube of integers. All of these I'll show you how to find it in this video. Okay. All right, so I would like to briefly talk about what we mean by integer. What do we mean by integer? When we are talking about integers, integers. These are negative and negative and positive, positive whole numbers, including, uh, including, including zero. Okay, including zero. That's what we call integers, positive and negative numbers, including zero. All right, and these integers come from the word Zealand, which is a German language, sorry. Okay, which means numbers. It means numbers. All right. So now let's move on to how to find the sum of these integers, the sum of square and cube of this integer. Okay. Now, if we want to find, we're having 1 plus 2, this is what we call the series. 1 plus 2 plus 3 plus dot plus n. This is what we call a series. Okay, this is what we call a series. If you want to find the, assuming you want to find the sum of the first 20 elements of this of these integers, now this is given as n plus n into bracket of n plus 1 over 2. Okay, this formula is not derived by just one particular mathematician. It has been existent for a while. Okay, especially the Pythagorean school. They have made use of this. A lot of mathematicians across India and across the Europe, okay, all the European countries, a lot of mathematicians have contributed to this formula. But the first man to make use of this formula was the man we called Carl Gauss. Carl Gauss. As a child, he was a child then. Okay, this man, or let me say this guy, make use of this variable concept in class. His teacher asked them to find the sum of the first 100 integers, and the guy raised up his hands and answered the question beautifully. Everybody was amazed. How do you get this? Okay, so the man that first makes use of this formula is this man we call Kanbos. Okay, so in today's video, I will showing you this variable concept so that you too you can amaze your teacher, student in school. Let's go now. So this is the formula. Now, if I want to find the sum of the first 100 terms of these integers, now our n is 100, so I'm going to make use of this. That is the summation of r starting from 1 to n, okay, over equals to n into n plus 1 or divided by 2. This is the formula. Okay, so we're having this now. I want to find the sum of the first 20 integers. Now we're having 20 into 20 plus 1, that's 20 plus 1 or divided by 2, which is equals to 20 into 21 or divided by 2. And 20 into 21, that is 20 multiplied by 21, I'm going to have 420, which is equals to 420, or divided by 2, which is equals to 120, 210, sorry, 210. So that's the sum of the first 20 integers. Isn't that beautiful? Okay, so now let's check what the man did when he was a child. Now his teacher is asking him to find the sum of the first 100 integers. Now this is what the guy did. Our n is 100 now, making use of this concept. So I'm having 100 into 100 plus 1, 100 plus 1 over all divided by 2, which is equals to 100 into 101, because 100 plus 1 will give us 101 divided by 2. So now 100 multiplied by 101, I'm going to have 10100 all divided by 2. Okay, all divided by 2, and this is going to give me 50, 50. All right, you can see this is beautiful, wonderful. Now use how to find the sum of the integers. Now let me ask you guys, can you tell me in the comment section what will be the sum of the first 500 integers? Oh my god, are you scared? Find the sum, sorry, find the sum of the first 500 integers. Let me know in the comment section. Wonderful. All right. All right. So now I want to show you how to how to find the square of these the sum of the square of these integers now. Okay. Now, if you have been given something like this, that is 1 squared plus 2 squared, this is what we call a series, plus 3 squared plus 4 squared plus dot 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 plus n squared. All right, now, so this is what we're having. Now I can find the sum of this to be equals to n into n plus 1 into 2n plus 1, all divided by 6, or divided by 6. Okay, that is the summation r starting from 1 to n. Okay, r squared this time around, okay, equals to n into n plus 1 into 2n plus 1, all divided by 6. This is the rule. So instead of you writing all these square one after the other, is 1 squared is 1 plus 2 squared, which is 4 plus 1, 5. 3 squared is 9, 9 plus 5. You can see that before you can find the sum of the first, the sum of this first, the sum of the square of the first integers, that will take a lot of time, and in fact you may find it difficult, impossible to do. Okay, now I will find the sum of the square of the square of the first 50 of the first the sum of the square of the first 50 integers now. So that's what I just want to do now. So that tells us our n is 50, because that's the number of times we are looking for. So we are going to have a summation r to 1, r starting from 1 to 50. That's our n. Okay, r squared equals to, all right, we are going to have our n to be 50. So I'm having 50 into 50 plus 1, okay, into 2 into bracket of 50 plus 1, all of these being divided by 6. All right, so this is going to give us 50 into 50 plus 1, that's 51. 50 into 51, okay, and then we're having 2 into 50 plus 1. Also, we are going to have let's say 2 multiplied by 50, I'm going to have 100. Let's do that. And then 100 plus 1, all right, all divided by 6. And this implies now, of course, that we're having 50 into 51. What is that going to give us? So 50 into 51, that is 50 multiplied by 51. I'm going to have 2,550. Okay, multiplied by 101. You know, 100 plus 1 will give us 101 over 6. This is equals to this multiplied 2550 multiplied by 101 equals to equals to 25 257,550, okay, divided by 6, and this is going to give us 42,000, sorry for that, 925, 925. Isn't that beautiful? Wonderful. Okay, you can see how easy it is. All right, let me ask you guys, can you find the sum, find the sum of the square, of the square of the first, of the first 100 integers now, integers. Go ahead and do that for me, okay? Go ahead and do that for me. I'll be expecting your solution in the comment section, okay? All right, guys, we have done the sum of the integers, the sum of the square of integers. Now I want to show you how to find the sum of the cube of the integers, okay? That is, if we are given something like this, 8 to the power of 3 plus okay, don't let me use this. Let me say 1 to the power of 3 plus 2 to the power of 3 plus 3 to the power of 3 plus 4 to the power of 3 plus dot 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 n to the power of 3. Okay, this is equals to n plus 1 over 2 all squared. Wonderful. Oh my God, I really like this beautiful concept. So this tells us that the sum of the integers squared will give us the sum of the cube of the integers. Okay, you know, n plus 1 over 2, sorry, into n into this, n into this squared. You know, the sum of the, you know, the sum of the integers is given as n into bracket of n plus 1. Okay, now all divided by 2. Now this is telling us that if we want to find the sum of the cube of integers, we are going to have the square of that sum of the integers. That is n into n plus 1 over 2 squared. Okay, now let's dive in together. Let's find the first 100, the sum of the cube of the sum of the cube of the first 100 integers, 100 integers now, 100 integers. This is what we want to find. That is our n equals to 100. So I'm going to have, of course, now summation r starting from 1 to 100, which is our n of r equals to, instead of equals to n into n plus 1, okay, all divided by 2, and then we square them. Okay, so now this of course implies that I'm having, what will be my n? Our n is what? That should be the terms we are looking for, that is 100 into, now we're having 100 plus 1, which is 101, okay, all divided by 2, but we are going to square this, which is equals to, you know, if you can remember vividly, for the sum of the first 100 integers, you get 5050, 5050. Okay, so that means this is 5050 squared. Okay, and this is going to give us 5050 squared. That's equals to, oh, this huge. I'm going to have a 2550 2500. Okay, wonderful. Oh my God, you can check that with your calculator. Okay, multiply by 1001. Okay, let me check. Because to these are, okay, having this. Oh my God, this is wonderful. All right, guys, I hope you understand this variable concept. I hope you get what we are trying to say. So this is the sum of the cube of the first 100 integers. All right, can you now look for the sum? Find the sum. Find the sum of the, sorry for that. Find the sum of the first cube, or the first 10 cube uh, of the integers. Okay, this is what I'm trying to say. We are having 1 to the power of 3 plus 2 to the power of 3 plus 3 to the power of 3 plus dot 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 plus 10 to the power of 3. Find the sum. You find the sum of this. What are we going to have? Okay, let me know your conclusion in the comment section. If you like this kind of video, don't hesitate to invite your friends to my channel. Follow me so that whenever I upload a video, you'll be the first to upload. Don't forget, this is Mathematics Learning by Tutor Chris. Thank you. Okay, bye bye.